Hi, my dear students. Today I came with a new topic in our class 10th mathematics. Class 10th mathematics. Okay, so previously we were discussed related to concept of sets, construction, and at the same time progression lessons. If you have not gone through it, please see those videos also. Okay, in playlist you can find the lessons, names and as well as classes. So I told you in the last session itself, the main motto of this channel is giving a fruitful, whole, full-fledged classes of Telangana State Mathematics subject videos content to you, because most of the students will unable to pay their tuition fees at home and they cannot able to afford it. But from my side I can able to help you in this way so that you can able to gain more subject from my side. Okay, myself Hatiram, discussing a 10th class mathematics. Today's chapter is trigonometry. Okay, the contents which we will discuss in this class, whole concept we will discuss in the next class onwards. Do these questions and exercises we will discuss. So content will be present in it. Okay, so the main and first content, why we have to learn this trigonometry and what is the introduction of it is, and in our daily life where it will be helpful to us. Next, naming of sides in a right angle triangle. If there is a right angle triangle is there is a three sides will be, then what are the names will be for that. Next, defining the trigonometric ratios. Okay, what kind of trigonometric ratios we have and how we will get their names. Next, trigonometric ratios for specific angles. So some of the angle related questions will be in this lesson. So we will also discuss how and what are the values of that particular trigonometric ratios. Along with that is, we will also discuss regarding to the complementary trigonometric ratios. Okay, so if there is angles are complement, then how does the trigonometric ratios are get changes? That is we will also observe in this particular lesson. And apart from this is trigonometric identities and related numericals. So if you see in our daily life, you can find these kind of things in our surroundings. There is a rope will be, there is an electric pole will be. Electric pole is mounted from the ground for the supporting rope. This supporting rope is making some angle at this particular point. So this kind of situation, if you see, pole is a straight line. Okay, from the base onwards some distance we were tied one rope, so it is making some angle. So at the ground and pole, if you see, it is making 90 degrees, then it is nothing but the right angle triangle we will call it as. So in the right angle triangle, so depending upon this angle, this side, this is, and at the same these three sides lengths are get varies. So how does it is varies? So how much length of rope need to be fixed? If there is a small length is there, how much length of rope should be chosen, or what angle if you will there, so that how much length of rope is required. Such a kind of thing we can able to find with the help of the trigonometric ratios. Apart from that is, here there is a person washing a wall, okay, or he's painting the wall. Okay, so he placed one ladder. So this is a ladder, so this is a ground. So ground will be the plane, wall will be like this. This is nothing but a ladder. So if he want to climb more height, then how much angle he need to place? The common sense will say us, but even though for the large distances, these angles will help us. So small lengths, simply with our common sense, we will do this is trigonometric ratios, but The normally, if there is a length is too high, like a bridge rope is there, how much length of rope is required, or how much angle we should place, and how far we can able to fix. Everything we can able to find with the help of angles and as well as a sides combination. Apart from this is, and there is one more example. You see, there is a person or a boy is playing on the slider. So how much length of slide is required? That can be no, depending upon its height and as well as length. So that we can able to calculate with the help of Pythagoras theorem. Okay, or if you know the angle, okay, length of slide we have, so how much angle we should place, so that how much speed the person has comes down or the playing boy will come down, or if you can increase the length or we can decrease the length. So all kind of actions can be performed with the help of same trigonometric ratios here. So you can see here the one more example is what this example is saying to us. So if you want to go, there is a small height, then angle is get a decrease here. If you want to large height, then angle getting a increase. So depending upon the angle there is a opposite whatever there to this angle. So that height is get adjusted. At the same time, the base is getting decreased. For the same ladder, for two different angles, different heights we were climb, and we can able to paint the wall here, or we can able to perform the action. So in this way, the different situations we are using these trigonometric ratios. So now if you see, as we know that where we will use, then come to know that how we can name these trigonometric ratios helpful with the help of their sides. Let us see, there is a side is nothing but a trigonometric triangle, right angle triangle we will draw here. Here one more side if you will place as like this, then it became a right angle triangle. Name it is ABC. Triangle ABC is a right angle at B, so that the angle can be possible either at A or it may be possible at C, because already we know this is right angle. Then let us imagine the angle is represented with a symbol called theta. Then let us say this is the angle. Then how we can name the sides? Okay, name the sides of right angle triangle. Okay, name the sides of right angle triangle. So the side which is opposite to right angle, it is called as a hypotenuse. So this is AC is called hypotenuse. Next, the side which is opposite to angle's opposite side is called opposite side. Means here in this case particularly BC is called as a opposite side. The side which adjoining to the angle, it is called as a adjacent side. So it means AB is called as a adjacent side. Okay, so if there is an angle is present at A, then these are the names of a side. Okay, if in case if there is another triangle is taken, and in this case if you will feel that okay, the side angle is present at B means C. So if angle is presented the C, then what we can do? So this is nothing but A, this is a B, C. Same triangle, but this time angle is present at C. If angle is present at C, as we know that the angle which is opposite to the hypotenuse is called as a opposite to right angle is called as a hypotenuse. AC is similar, that is nothing but a hypotenuse. The angle which is C opposite is called as a opposite side. Now opposite side is getting changed, that is AB is equals to, we can call it as a opposite side. So my dear students, you have to understand here that what I am saying. So if angle is get changed, opposite side is get changed, angle adjoining side, okay, is nothing but adjacent side. So that is BC is called as adjacent side. Okay, my dear student, do you understand what I am saying? Okay, so if one more triangle if I will draw, then you tell me now. So there is a triangle is get drawn as like this. So here is a right angle. Let us name to this is A, B, C. Angle is present at A. So now answer me, what is hypotenuse here? This is a right angle, right? Opposite is called as a hypotenuse. This is an angle whose opposite is called as a opposite side. Okay, then one more is nothing but adjacent side. Okay, then you know the three sides. Then if you know three sides names, then according to the Pythagoras theorem, if any two of sides are known to us, then we can able to calculate third side by Pythagoras theorem. What it is says simply, this is A, B, C, right angle triangle. 3 centimeter and 4 centimeter are sides. What about the AC? This Pythagoras theorem states that if there is a two sides are known to us, okay, then third side, that is hypotenuse, is nothing but hypotenuse square is equals to square of the adjacent sides of sum of the squares of adjacent sides of right angle, that is AB square plus it is a BC square. So AB is 3 square, BC is 4 square, which is the 9 plus 16. Together what we can say is it is 25. So AC square is 25. We don't want AC square, we want AC value, that is under square root of 25, which is nothing but 5 centimeters. So if you know two sides, third side is nothing but under square root of the AB square plus BC square. Okay, my dear students, AB square plus BC square. Is it clear? Next, one more example problem we will do on the basis of sides. Let us see. There is a triangle whose hypotenuse is given this time. It is 10 centimeters. Base is given 8 centimeters. What about this is A, B, C. Now this time hypotenuse is given, one side is not given. So in that particular case, we can able to solve again the Pythagoras theorem with the help of that is hypotenuse square is equals to AB square plus it is a BC square. Sir, always ABC will be a no. There is no need to take ABCD. You can take PQR also, or you can take small ABCs also. You can take it. So, as hypotenuse is given 10 square, which is equal to adjacent is not given AB square, then base is given as a 8 square. So it is a 100 is equals to AB square plus 64. Then transfer this is, so 100 minus 64 is equals to AB square. Then as we don't want AB square, we want AB, then subtract it is, we will get 36. Square from this will go that side, it will become root. So answer is 36 centimeters. Okay, so if you know two sides, third side can be find hypotenuse square minus side square is nothing but the another side. In there is a two sides will be no side 1 and as well as side 2. Side 2 can be find as like this, under square root of hypotenuse square minus known side square. You can use this formula. Okay, is it clear? Hypotenuse, how to find? Hypotenuse is nothing but side 1 square plus side 2 square. Sir, side 1 and side 2, what these are? Side 1 means you can take either this is a side 1 or this is, you can take it as a side 2. Or you can take that is side 1 or this is nothing but side 2. With the help of this is you can able to find if there is a two triangles sides are known, that is third side hypotenuse we can find, or if hypotenuse is unknown then we can able to find side 1 and as well as a side 2 with the help of this particular formulas. Okay, so here we were completed introduction part and we were also completed naming of triangles. Next, defining the trigonometric ratios. So let us see. As we have seen, there is three sides of a triangle. That is nothing but if there is sides are like this. So if this is nothing but one of the side, then take it one more side as like this. So base I am drawing. Sorry. Let us take this is third side. We will take it one more side. Okay, third side. So next side, that is third side, if you will see here, it is a AC. Okay, now there is name the sides. Right angle opposite is called as a hypotenuse. The angle either it may be represented with a curve. Curve means angle only, or either represented with a theta. So theta opposite side is called as a opposite side. Okay, next third side we know that the adjoining of this angle is called as a adjacent side. We have three sides here. Okay, that is one is opposite, another one is adjacent, and as well as hypotenuse. So simply to remember these trigonometric ratios, very small trick will be that is. Okay, opposite hypotenuse, then opposite adjacent. OAO, HHA. If you remember this small table, that is OAO, HHA. Then from the reading from top and as well as the bottom, you will get the trigonometric ratio. What if you read from the top, that is opposite by it is hypotenuse, then we can call this is nothing but in full form cosine sine of angle theta, or in short sine theta. Okay, what is the side opposite here? AB. Adjacent, what is that? Adjacent, hypotenuse is nothing but AC. In next, you read from the top, adjacent. Okay, by it is hypotenuse. Adjacent name what here? BC. By it is called as AC is hypotenuse. This ratio named as a cosine of angle theta, in short cos theta. Next, read from here. O by A opposite, by it is adjacent, sides these are. Then opposite by adjacent is called as a tangent of angle theta, in short tan theta, that is AB upon it is BC. See, if you make a ratio of these two, then also AC will get cancelled, then AB by BC only will left. Means it is also can be called as AB by AC by is BC by AC. So AC gets cancelled, that is AB by AC, which means sin theta by cos theta, which is called as tan theta. Okay, so in this way also we can say its name. Okay, then again make the table here. We cannot see the top of screen at the same time. What is it? OAO HHA. Now read from the bottom onwards. What is that? Hypotenuse by opposite. What is the hypotenuse opposite ratio? Name is cosine. COSEC. Cosec. It is theta. Okay. Cosec. Is it clear? Next, if we read from the here onwards, what is that? Hypotenuse by adjacent. So hypotenuse by adjacent is called as simply sec theta. Sec theta. Next, read here. That is what the another one is adjacent by it is called as opposite sides. Okay, the ratio is becomes the cotangent, simply cot theta. So if you observe properly these are, then they are simply the notations of it is 1 by sine theta, because sine theta is opposite by hypotenuse. Now hypotenuse by opposite is there, then we will say 1 by sine theta. This is what it is, 1 by cos theta. Okay, cos theta is adjacent by hypotenuse. Hypotenuse by adjacent means we can write like a cos theta. This is what opposite by adjacent is called tan, but adjacent by opposite is called cot. So simply we can say 1 by tan theta. Okay, now the names what we were learned till now. So sin theta is called as opposite by hypotenuse. Okay, cos theta is simply called adjacent by hypotenuse. Okay, tan theta, it is nothing but simply opposite by adjacent. Then 1 by sin theta is called as cosec theta, that is hypotenuse by opposite. So then 1 by cos theta is called, it is sec theta, it is hypotenuse by opposite. 1 by tan theta is called as cotangent, cot theta, simply called adjacent upon the opposite. So how to remember easily? Simple table. Okay, that is O A O H H A. So with this table we can remember the trigonometric ratios and their names easily. Okay, naming is completed. Then the trigonometric ratios names we were heard. Okay, next so this is done. What is the next? Third concept, defining trigonometric ratios is completed. In the next class we will see the remaining concept. Okay, my dear students, have a great day. Thank you. I hope you enjoyed this class.